graphing out some sinusoidal applications, and now we're going to give you the equation and then answer some questions about it. So this is the tide at Boston Harbor. It's modeled by that equation. So the first thing we want to do is we want to pick apart the equation. So I'm just going to scroll down to the equation here. This is our A value. If you remember, our A value equals our amp. So our amplitude is 2. What's our B value? Pi over 6, yep. And how our B value helps us, it allows us to find the length of a revolution. So we plug it into that equation. Period equals 2 pi over B. So 2 pi over pi over 6. What we have is a fraction dividing another fraction. So I'm going to change it to multiplication. So I'm going to take 2 pi over 1, change it to multiplication, reciprocate the pi over 6 as 6 over pi. Now you'll notice the pi's are going to cancel. We multiply across, and we get 12. So the length of our revolution in time, in hours, is 12 hours. So one revolution is 12 hours. Now, is there a phase shift? Is there a plus or minus C? There'll be a D. Yep, there's a D. Here's our D. And that tells us vertically we're going up 4 units. All right, so we're going to go ahead and graph it. We have to get 12 months down here. Here's 2, 4, 6, 8, 10, 12. Okay. Then we're going up 4 units. So I'll say this is 1 unit, 2 units, 3, 4, 5, 6. So we know the first thing I like to do is I like to graph my vertical axes shift up. So my new principal axis is at 4. This is y equals 4. Then I don't have a phase shift at all, horizontal or vertical, so it's going to start at time of 0. And then our length is 12 hours. So we're going to start and stop our revolution in 12 hours. So if you remember graphing, we like to graph them and separate our period into 4 equal segments. So our halfway point would be at 6 hours. And then our halfway point would be at 3 hours. And our halfway point would be at 9 hours. Okay? All right. Now you'll see your amplitude is 2. So your graph is going to go between the values of 2 to 6 feet on the vertical axis because our amplitude was 2. Now the trig function they give us is a cosine function. Cosine functions without a reflection always start at the top of the amplitude. And we're set to go to graph it. So we start at the top, to the bottom, or to the middle, to the bottom, to the middle, to the top. So now this is our cosine function. All right. Now here we're going to go ahead and answer the question. Between time of 0 and 12 hours, is the tide at least 5 feet? How many hours is that true? So now let's look at it graphically. So we're going to go and look on the vertical axes. Here's 5 feet, right? So now let's draw a line. Do you agree that this time right here, and chop that to 12 hours, and this time right here is the time that it's above 5 feet?
Yeah.
So how many hours is that?
6.
This distance here is 2 hours. This distance here is 2 hours.
Oh, wrong.
Do you agree? 4 total hours that the Boston Harbor's tide is at least 5 feet. So our answer is 4 hours.
Wait,